Hello everyone, I am Dr. Hulas Tonde, Assistant Professor, Department of Mechanical Engineering, Shreyas College of Engineering and Technology, Aurangabad, Maharashtra, and today we are going to talk about control systems. So this topic comes under the subject Mechatronics, and the content of this topic is based on the syllabus of D. Bartu University, Lonere, Maharashtra. So what is control system? So a control system is a system which provides the desired response by controlling the output. The output is controlled by varying input, and that is the reason the control system got this name. We will vary this input with some mechanism. So we can say that a control system in any system or any electronic device, we want desired responses or desired output. For that reason we have to control the output. So output can be controlled by varying the input. Whatever the input signal we are giving to a device or machine, it should be varied depending on the desired output. So the best example of control system is traffic light control system, washing machine control system, fan regulator, heater, AC. So there are several machines which needs controls. So a control system can be stated as the system which controls the other system by its output. So this is another way to say that a control system controls the other devices, other machines by its output. So the purpose of control system is to make a plant or process behave in an intended manner according to some performance specifications. So any plant or any process has to be controlled based on the instructions of the user or based on the instructions of the operator, but there is some performance specifications which plays a major role in a control system or in controlling a process. So the overall system that includes at least the plant and the controller is called the control system. So in any control system we have the controller, plant, input signal and output signal. That is the important thing for any control system. So a good control system should satisfy performance requirements concerning such attributes as, so there are several parameters which are considered as the performance requirements or performance characteristics, like accuracy in the system, what level of accuracy you want at the output of any machine. Stability of the signal means what is the stability at the output of the control system or controller. Then speed of response, what is the speed of response or bandwidth of the response. Then sensitivity of the system and the robustness of the system. So these are the parameters which plays a major role in a control system. So now why control system? So control problem becomes crucial due to such reasons. So there are several reasons due to which the control is important or controlling is important. So complex systems, so there are several systems that may be the many inputs, many outputs, dynamic couplings, non-linearities. So these are the parameters increases the complexity of a machine or complexity of a system. So these are the regions we need control systems. Then rigorous performance specifications. So if you want high degree of specifications or high level of performance specifications, then you need a control system. Then unknown excitations, if there are unknown inputs or disturbances or noises in the system during its performance or during its operation, then you have to control the inputs of a system which should be free from the disturbances or which should be free from the unknown inputs or unknown parameters. For that reason you need a control systems. Then unknown dynamics, like incompletely known plant. Okay, means in some of the system there are unknown inputs, but in some of the system there are unknown, plant is also unknown or process is unknown. So for that reason you need a control system that can operate based on the user instructions. Then another parameter is to increase productivity of the system, then to improve performance of the system. So these are the common problems or common regions for which we need a control system. Then terminology for control systems. So there are several terminologies for control system, and some of them are stated here. So first one is the inputs. So excitations. Inputs of a control system are also known as the excitations. Then these may be the known inputs or unknown inputs to the system. Okay, so the controller, then controller, this is the main part of any control system. So controller is the device that implements the control law or generates the control signals or actuating signals. So controller implements the control law. Whatever the control instructions you have inputted in the controller, that will be implemented in the output. So plant or process. So plant or process component of any control system is the system to be controlled. If we want to control the speed of a fan, speed of a motor, then the motor will be the plant. Then sensors, the devices that measure the system variables or excitations, responses. So sensors are in a control system also plays a major role, and which measures the or which detects the control variables of a system. Then actuators, the devices that drive various parts of the system. So actuators are the devices that may be the power generating system for various devices of the control system. Then outputs, so responses of the system. So if we want to measure the speed of a motor, then output will be the speed in RPM. So responses of the system. Okay, if you want to heat the room, then and we want to measure the temperature of that room, then the temperature will be the output for that system. Then control law. So control law is the relation or scheme according to which the control signal is generated. Means control law is the instructions or scheme or program according to which the control signal is generated by the controller. So these are the terminologies well known for the control system. Then classification of a control system. So control systems can be classified based on different criteria. So there are, first one is the manually and automatic control system, that is also known as the manual control system or automatic control system. So as the name indicated, manual control system is the system which is controlled by the human body. Okay, then the automatic control system is the system which is controlled by the automatic system or use of the automatic machines, that may be the microcontroller or microprocessor, PLCs, etc. Then continuous time and discrete time control systems. So there are the another type, CISO and MISO control system. Then SISO and MIMO, CISO and MIMO control system. Then open loop and closed loop control system. So these are the types of the control systems. So first we will talk about the continuous and discrete time control system. So based on the type of signal used, this classification has been done. So in continuous time control system, all the signals are continuous in time, or all the systems are continuous with respect to time. Then in discrete time control system, there exists one or more discrete time signals. So here we can say continuous time and discrete time control signals. So here you can see continuous time control signal means these signals are continuous with respect to time. Means if you want to get the information from here to here, how this signal reaches from 0 to this top level, so all the informations are continuous. We can get the information with respect to time. Then in here we can see discrete time and discrete amplitude. So here there is no continuity of the system or signal. Here the signal is 1, and after that there is a 2 3, then again it comes to 1 and 0. So the signal strength or signal amplitude is varies with respect to time, means in discrete time. So there is no particular information in between these two time domain. So here this is the discrete time and discrete amplitude, and this is the discrete time and continuous amplitude type of signal, and this is your discrete time and discrete amplitude type of system. So these are the control signal can be based on these two systems. Now SISO and MIMO, these stands for the single input and single output type of control system. So these systems have more than one input and more than one output. Then this SISO means single input and single output, means this will have only one input and one output. Then multiple inputs and the multiple outputs. So this kind of control system have the more than one input and the more than one output. So for example, here we can see open loop control system. So here if there is this is one input and one output, so this comes under the single input and single output control system. If you have multiple number of inputs with the controller, then multiple number output from the plant, so this will be known as the MIMO, multiple input and multiple output control systems. So after that we will talk about the open loop and closed loop control systems. So open loop control system is a widely known control system, and it is also used in several systems or machines. So in open loop control system, output is not fed back to the input, means there is no feedback system in this type of control systems. So the control action is independent of the desired output. So in this open loop type of control system, the control action, we want to control any device, so the control of that device is independent of the input signal received to the controller. Okay, then an input is applied to a controller and it produces an actuating signal or controlling signal. So an input is applied to a controller, means here input is applied to the controller and the controller produces the actuating signals. So this actuating signal works as a input for the plant. Now this actuating signal is received by the plant, and the plant has been controlled as per the actuating signal or as per the controller. So in open loop control system there is no feedback system, means there is no relationship between means input does not, our controller does not receive any information from the output signal. Okay, means it is one way, one directional control. So for example, the automatic washing machine is there. So in automatic washing machine, the open loop control system has been used, means the automatic washing machine is based on the time. If you want to fix, if you have fixed the time 15 minutes, then it will run the machine for 15 minutes and it will stop. It will not bother about the your cloth is shining or not, or your cloth is clean or not, it will run to a particular time, or it will run if you set the strong, or it will if you set your machine in the normal level. So it will work based on the time only. It is not a worry about the your output, means the cleanliness of your cloth. Then automatic tea or coffee maker, so it also works on the time based system. If you said that it will run to the 1 minute, then the machine will run for the 1 minute, even though your tea or coffee will cooked properly or not. Okay, then light switch or fan switch, if you, so these are the one way control system, means if you switch on the light, it will run the light or operate the light over the until you will not switch off the light. Okay, even though in the daytime. Okay, so it will not bother about the output, means the control is not based on the output, it is based on the time or the user. Then electric hair dryer is also there. So if you set, if you pull the switch, it will run, and if you pull off the switch, it will not run. Now there is the closed loop control system. So in closed loop control system, output is fed back to the system, so the control action is dependent on the desired output. The error detector produces an error signal, which is the difference between the input and the feedback signal. This feedback signal is obtained from the block or feedback elements by considering the output of the overall system as an input to this block. Instead of the direct input, the error signal is applied as an input to the controller. So this is the closed loop control system, where we can see there are the main elements: input, controller, plant, output, then feedback element is there, which is now the feedback element is not found in the open loop control system. So here we can see input is sent to the error detector system. So initially input is directly sent to the controller, then the controller generates the actuating signal based on the instructions of the user. Now the actuating signal is the input for the plant, and the plant receives the actuating signal and operates based on the actuating signal. Now this plant send signal to the output. Now in between there is the junction, which connects the output from the plant and the feedback signal. Now the output from the plant is input for the feedback element, and this feedback element generates the feedback signal, which is sent to the error detector. Now this error detectors measure the difference between the input signal and the output signal. For example, if you want 200 rpm at the output for a motor, then we have to set a proper voltage supply from the input. If we set 200 volt at the input, then we receive 180 rpm at the output, and we want 200 rpm. So there is the difference in the rpm value, that is the 20 rpm difference from the desired output to the actual output. So this will be measured by the feedback element and detected at the error detector, and as the error is detected, the input signal has been adjusted by the controller so that we will get the 200 rpm at the output of the motor. So there are several examples or real examples of the closed loop control systems. So these are the servo voltage stabilizer, which is based on the output of the system. If you want to receive 250 volt at the output, and then you can vary the signal at the input, then you can increase the level of the stabilizer and you will get the 250 volt at the output. Now water level controller. So water level controller is another example of closed loop system in which there is the feedback signal from the reservoir. If the reservoir is filled with water, then the feedback signal will send to the input of the controller and say to stop the motor pump. If the reservoir is unfilled or half filled, it will send the feedback that you will run the motor pump until the reservoir is filled. Now air conditioner is another example which is best where there is the sensor, temperature sensor, which senses the temperature of the room and accordingly it operates. Now the cooling system in the car, so where there is also a sensor, temperature sensor, which senses the temperature of the car, and based on that temperature at the output, feedback has been sent to the AC system and controller, and controller controls the operation of the AC based on the temperature at the output. If you want 25 degrees Celsius at the output and the temperature is above the 25 degrees Celsius, suppose the temperature is 30 degrees Celsius, and if you want to reduce the temperature to 25 degrees Celsius, then controller will be set to run the AC system to reduce the temperature. And when the temperature is maintained at the 25 degrees Celsius, the performance will be, or the operation will be reduced, or the speed of the AC will be reduced to a particular fixed level, so that you will get the temperature at the 25 degrees Celsius. So this is the closed loop control system. Now this is another example where there is the user interface is also associated with the closed loop control system, where there is the digital computer, keyboard is there. Now signal conditioning amplifier is there. Now process or plant is there, that is the robotic arm. Now the actuator is there which runs the sensor, and through the sensor the response is recorded, and through the sensor the feedback path is signal conditioning or filtering system is sent to the input again. So this is the another example of the control loop system. Now there are the differences between the open loop system and the closed loop system. So open loop control system is independent of the desired output, but the closed loop is the dependent of the desired output. Now feedback path is not present, feedback path is present. There are also called as non-feedback control system, and these are also called as the feedback control system. Now easy to design, difficult to design. These are economical, these are costlier, then accuracy is low, then here the accuracy is very high. Now we are going to talk about the transfer function in control systems. So transfer function can be defined as the relation between the output signal and the input signal of a control system. So there is the relationship between the input signal and the output signal. So that relation is governed by the transfer function. For any control system, there exists a reference input known as excitation or cause. So this reference input is the important excitation in the transfer function or any control system. So this reference input operates through a transfer operation or transfer function to produce an effect resulting in controlled output. Means there is a controlled output obtained through the transfer function only. So there is the reference input which is governed by the transfer function, and we will obtain the desired output or controlled output. So simply the cause and effect relationship between the output and the input is related to each other through a transfer function. Now, so here we can see there is an input and there is the transfer function in between the input and the output. So this is the important parameter considered as the transfer function for any control system. So here suppose Rs is the Laplace transform or transfer function, Laplace transform for the input, and there is the Ys is the output. So in any system, suppose we want a vertical position for a machine, then we set the controller by providing a particular control law or control instruction. Then elevator dynamics will be there will be some formulation or equations which governs as a transfer function, and then we will obtain the result as per the transfer function. So this is the transfer function. So mathematically it is defined as the ratio of Laplace transform of the output variable to the Laplace transform of the input variable, assuming all initial conditions to be 0. So here suppose this is the GS, that is the transfer function, so which can be calculated by using this formula. So transfer function is the ratio of the Laplace transform of the output variable to the Laplace transform of the input variable. So Cs is the Laplace transform of the output variable and Rs is the Laplace transform of the input variable. So now the procedure for determining the transfer function is, we form the equation for the system. For any system we form the equation like this, means even though it is a key function, we form the equation, okay, of any system. So we create the equation for the system, then we will take the Laplace transform of the equation or system equation, assuming initial condition as 0. It specifies system output and input, means suppose this is the equation, suppose this is the system equation, we transform into the Laplace transformation, okay, then specify system input and output. So system input and output will be specified and their Laplace transformation will be specified properly. Then take the ratio of Laplace transform of the output and the Laplace transform of the input, which is the required transfer function. So we will determine the ratio of both the transformation. Now the important thing is, output and input of a control system are of same category, means output signal and input signal of this control system should be of the same category. So we will find the Laplace transform by using this equation, means transfer function for any control system can be obtained by using this system. There are other methods for calculating the transfer function also, but those things we will discuss later on, and today we will stop our lecture over here. So thanks for watching. If you have any question, you can write in the comment box. Like, share and subscribe my channel. Thank you so much.